Okay, so we're going to talk about chords and arcs of a circle. So let's recall that a chord is a segment that has both points on the circle. Okay, this would be called the arc of the chord. Talking about the outside, so this would be the arc of the chord. Okay, so there are several theorems and special relationships that happen. So first of all, let's talk about if you have a chord and you have a radius that is perpendicular to the chord, then what happens is, let's try to zoom in here. What happens is the chord is bisected. Okay, so if a radius is perpendicular to a chord, then the chord is bisected and the arc of the chord is bisected. So that means also that this little piece of the chord is congruent to that little piece of the chord. If we have another circle with chords, some letters in here, this is A, B, and C, D. So if chord AB is congruent to chord CD, then arc AB is congruent to arc CD. So if I know that these chords are congruent, then I also know that the arcs are congruent. And you can also do the converse of that, meaning if the arcs are congruent, then the chords must also be congruent. Notice what I'm doing is I'm making sure that I'm using the symbols because we have arcs and we have segments. Okay, so we're going to do the first example. And we have a circle. We have two diameters. So if chord VT is congruent to chord, I forgot the chords, RP, then what can we conclude? Okay, so if the chords are congruent, we are given that information, then what can we conclude? Well, we just talked about that in the previous example, that arc VT would be congruent to arc RP. And we can conclude something else, which we've seen back in proofs, and that is this bow tie figure. So because of that, I know that these angles are going to be congruent because of vertical angles. So angle VOT would be congruent to angle ROP. Okay, example 2. Make sure you're not looking at the scale, because these are definitely not to scale. So this is X. This little piece here is 6. Zoom in. This little piece here is 7. And this little piece here is 7. Notice they are not a radius because they do not go all the way through to the circle. And then this chord is 12. Okay, talking about, notice these chords are equidistant. So I'm going to add a little note there. If chords are equidistant, which means the same distance, from the center of the circle, then the chords are congruent. Okay, so if I'm looking at distance, this is 7, so this chord is 7 units away, and this chord is 7 units away, so then I know that this piece is 12, so then this piece also has to be 12. So that means that x plus 6 has to equal 12, which means that x has to equal 6. In the last example that we're going to do, so this piece is x, and this little piece is 5, and that little piece is 5. Okay, so we know a couple different things just by this diagram. If this is bisected, then we know that this is perpendicular. Okay, so if the chord is bisected, then the radius is perpendicular to the chord. So 5 and 5, which means it's perpendicular. Look at my drawing a little bit closer, and this is a radius. Well, so is this. So I'm going to take out this triangle, so we're going to focus on that triangle. So that is 9, that is 5, and there's my x. So it comes back to the good old Pythagorean theorem. So I have x squared plus 5 squared equals 9 squared. X squared plus 25 equals 81. X squared equals 81 minus 25, which is 56. And grab my calculator. And I get about 7.5. So x is approximately 7.5.